arg of z minus 3 minus the arg of z equals pi over 4. So let's have a look at this one. First of all, this is the point 3 here, isn't it? Z minus the point 3. This is the point 0. So we can mark off that point there, which we already have done, of course, the origin. So a point here, the argument of z minus 3, take away the angle z minus 0 makes, and we get pi over 4. So I hope you can visualize a pair of scissors, because that's what I'm going to draw. And the angle between the scissors is going to be pi over 4. So here's the z minus 3, say. Let's go up there. And here's the z minus 0. Now that angle between the two is a difference of pi over 4. So hopefully you can see that there. And I'll just illustrate it in a moment. So if I drop a perpendicular here, this angle here. So basically the angle z, arg of z minus 3, which is here, that angle which we'll call alpha, and the arg of z minus 0 which we'll call beta. So here, alpha minus beta equals pi over 4. So if you think about, this is 90. So this angle here, if I do a horizontal now, hopefully that's not too confusing. This angle here is just the angle beta. There. This angle here is the angle alpha, of course. That angle was alpha. That angle was beta, and alpha minus beta must be here, which must be pi over 4. Okay, that's good. So that point there is the point Z, and that satisfies the condition that's specified in the question. Now, an angle, if we think about this as a chord, for example, this angle here, which is 45, is, if it is on the circumference of a circle, would be half the angle at the center of a circle. And we know the center, if we draw, imagine OA to be a chord of a circle, for example, then, and that would be on the circumference, then we would know the center. We could do a triangle here, and the angle here would be 90, wouldn't it? Because it would be twice the angle of the chord. The angle at the center is twice the angle of the circumference. That's a property of a circle. So if that value is 45, this value is 90, and now we can get where the center of this is. So any point on this chord here, and on the circumference must be 45 degrees. This angle in here. And if that's 45, this is 45 degrees. And the difference between the arguments then must be 45 degrees, which is what we wanted. So that's a property that's specified by a circle, isn't it, here? So all we need to do is get the center. So C has coordinates then. So what have we got? Well, this distance is 3, so half the distance is 3 over 2, because I've put a perpendicular here, bisector, between O and A. So this is 3 over 2. This is 90-degree triangle. Okay, so this is 3 in total. Okay, this triangle here, there's a 90 there. So if that's 90 and there's symmetry, this is pi over 4, 45. So this is 45 here. So we've got 3 over 2 and 3 over 2. So I'll just draw it here just to illustrate it more clearly. This is half our circle. This is C, this is O, this is 3 over 2. We said that the angle here was pi over 4, so this is pi over 4. 3 over 2 tan 45 is 1, so this is 3 over 2 as well. Then you've got the proportions 1, 1, root 2, so this is 3 over 2 root 2, because it's a 1, 1, root 2 triangle in proportion. So there's our radius then. The center is here, so the x distance from O is 3 over 2. The y distance from O is 3 over 2. And radius, radius is R here, 3 root 2 over 2 over 2. So we can write down the x minus the value 3 over 2 squared plus y minus 3 over 2 squared is equal to the radius squared. Cancel by root 2, you've got 3 over root 2, that's 9 over 2 when you square it. So these points here have the property that the value of the angle here is half the angle at the center. The center angle here is 90, we've said, and that angle is then 45, which is what we've got inferred from the diagram. So we can basically go round here. That's a chord of a circle. So we can draw our circle then. It's of center 3 over 2, 3 over 2. Radius is 3 root 2 over 2, which is going to come under here. So it's going to go round here, come through A, go round through here, go around to the top, oops, come through O, and go back through here. There's the circle, and there's the equation that characterizes the points on that circle subtended by the chord. So we've also got the condition y must be greater than or equal to 0.